What is SMR? What is this whole thing? So shingled magnetic recording. Think about it this way. A long time ago, well, when you think about how hard drives work, you just like, okay, we've got this spinning platter, and you're going to lay down this magnetic stripe on it. And at least in my mind, the way I'd always conceptualize it is that you've got this one layer of magnetic line coming down, and then they scoot over a little bit, and they write this other layer, and then the next one comes along, and the next one comes along, and you're like, okay, just makes a lot of sense. It's kind of like lanes on a highway or something like that. They line up right next to each other. Everything's great. Turns out that's the way they used to do things back in like the 1970s. And they do things a little bit differently now. So the traditional hard drives that we're all used to using as spinning media is using something called perpendicular magnetic recording. So imagine those lanes of magnetic flux, or whatever it's called, laid down on the spinning disk. But actually what they've done is they've taken those and laid them on their side, so they're vertically. They kind of like do some nice things with the material, so the magnetic charge goes vertically instead of just laterally through the surface. What that means is they can get a lot more density because you can start squeezing those together. So we've been using that for like the past 20 or 30 years. Yay. So those are called PMR drives, or perpendicular magnetic recording. We're going to refer to PMR drives quite a bit in comparing them with SMR drives. So SMR drives, new stuff. PMR drives, what you've all been used to with traditional hard drives. So what is SMR? What's the difference? Well, what they have done is starting to take those magnetic tracks and starting to overlap them just a little bit to squeeze them even closer together. So in this way, it looks kind of like this. You can think of it very similar to shingles on a roof. So you lay down one line, and then you lay down another one on top of it, and another one on top of it. And they'll do this for a certain band or zone, an SMR band on the drive surface, and they make a little gap, and they will then start writing down another SMR band. Now, I think that's pretty neat. That's pretty good. They've done some really clever things in the hardware, the actual read and write heads on the spinning media, and you can suddenly write something and then read just a little sliver that's still exposed. So does that make sense? Everybody with me so far? Now here's the problem. What happens if you want to overwrite one of those things that's in the middle? Well, because the write path is so large, what it means is you're overwriting that stuff that was layered on it. So let's say that you want to overwrite a byte that's right in the middle of one of these SMR zones. You then now have to overwrite, you have to read and then write down again, using the SMR pattern, all of the data that came after that in that SMR zone. What this means, and the end result here, is that you end up with something that starts looking like a linear access. Because the natural expression of this would be, imagine if the entire surface of the platter was written from the very very first LBA to the very last LBA on the drive. They would be all completely written with SMR. Then you would, if you wanted to modify one byte, you have to read the entire data, or at least every piece of data after that point on the drive, and then overwrite them all again, just change one byte. So that's why you break them into zones, and that's kind of, this is the cost you get of that density. So that being said, obviously this is not going to work just out of the box for anybody writing a new sort of application.